Good morning. Howdy. There we go. Let's just be Flynn's Arcade. Alright, smooth. Fade out. Oh, we need our little loopy thing here. There we go. So, welcome back to Wednesday. Got a lot to get through today, so we're just going to get right into it. We have homework due tonight, by the way, so make sure that if you've forgotten about that, keep in mind that we're doing that tonight. I've been getting a lot of questions from people on the homework about adding on lots of complexity. Um, does the user have to be able to enter in new products and stuff like that? And it doesn't have to be pretty or crazy functional. All I want to see is the separation of model, view, and controller in this. You don't have to go crazy. You can just simulate three or instantiate three objects, call them products, and that's good enough for me. Some of you are talking about reading in JSON files or calling out to databases or doing full-on web applications. You don't have to do that. Um, just keep it simple would be my suggestion. I'm going to care more about the connections between the pieces of your software. So just make sure everything's separated. Like the view should really just be displaying something. Like maybe display the user menu and a string where that string is filled in by a call from the model. Like the controller gets the input from the user, or the model displays the user input. You hit the number one, it routes that's the user pick number one to the controller. Controller calls the model. Model just returns product one. should the view be calling get methods from the model? It depends on your application and how you have it set up. So if I look at your class diagram and that is the case, that's technically fine. With MVC, it is possible for the view to directly talk to the model. Generally, you have the controller route things as necessary. Like the canonical view would be that view approach would be that your view renders a menu or buttons or a terminal 1, 2, 3, something like that. You type in 1, the view says, okay, 1 was returned. The controller sees that the user entered 1. Controller says model.get response for entry 1. That's a string that comes back. Controller sends that to the view. But your model and the view can talk to each other if it's a simple application. And the goal, though, is separation of concerns with that. But my suggestion is just don't go crazy. Oh, I should probably talk about, sorry, I wanted to get right into this and then I skipped right over the important bit. For your, let's see, announcements. Or am I thinking of something else? Did I talk about the unit testing for the final project yesterday or on Monday? Sorry, I'm losing my short-term memory in my old age. I must have. Yeah, unit testing was extra. I did talk about this. Okay, not that I remember. Okay, thank you. Yeah, so looking at the timing, I guess if you missed it, check this SRS or the final deliverable spec. Normally I would have you do unit testing as a requirement. I made it extra credit. That's the quick summary. I'm getting you all mixed up with my graphics class because I posted something for them last night for their final. That's fine. Too many moving pieces in my head. All right, let's get back to full screen here. So we ended here last time talking about interfaces, right? And we were kind of breaking down analysis versus design versus programming in terms of object-oriented things. This would be our design level, by the way. We've got a class diagram type setup here with interfaces, with aggregation, with inheritance. Basically, we're getting into constructing a program. And we are talking about interfaces. And the really nice thing with programming to an interface and why you want to try to use them as much as possible are for the many advantages that you see here. And I have to do mouse click because it doesn't like my keyboard input. So with an interface, we are kind of pulling apart the responsibilities of our program. We're designing one kind of a front end for all of your calls to be routed to things behind the scenes. Basically, we have this notion of coupling in classes, and that's how kind of intertwined classes are. And if they're loosely coupled, that means they're basically separate entities. And that's what you typically want with programming. Again, if we have classes that are well separated, you can reuse them. If you make an update to one class, it doesn't automatically mean you have to update 30 other classes. If it's, again, separate, it's its own thing, which is great for reuse, for flexibility, and for maintenance. Now, it does increase the complexity a little bit, and the amount of complexity depends on how crazy your application is. Here we have an interface where I'm moving some object up, down, left, right, where the objects under the hood could basically be a pixel, which can be extended to be a circle, a square, a generic polygon. It does get complex, right? So we have now 3 classes instead of, just 1 or 2. But it becomes infinitely reusable, which is really nice for savings down the road in terms of your time expended. So, can be nice. Here's another example for you too, which can help visualize this as well. This is for a vehicle type of interface. So with vehicles, they can be any number of types, right? A vehicle doesn't have to be just a car. It could be a truck. be a semi-truck, or it could be a transport if you're in Canada. Submarine, a boat, sailboat. It just kind of depends. But they're all going to have common function calls if you're going to instantiate this as a simulation, right? Move forward, go in reverse, turn left, turn right. It's going to differ based on the type, right? A car turning left is way different than a boat turning left. You're cranking a wheel and, reorienting the drivetrain underneath the car to go left, whereas a boat, you're turning your rudder the other way to divert water to go in a different direction, right? But an interface for this, if we were to simulate a vehicle, it's not going to matter. Left, right, forward, reverse. It's going to be the same function call regardless. And yes, we can add in other functions too that may not necessarily be used by each vehicle type, but they will be there, right? So if we have an interface here for I maneuverable, here's our generic function calls. Well, let's go ahead and just implement this I maneuverable interface, and then we can add our code to actually define those functions. And for a car, climb and dive might be just returning null. Or if we're climbing and you're diving, maybe we're going into four-wheel drive mode and going up like a steep incline or steep decline. Again, it kind of depends on your specific instance. So you see car, boat, submarine, airplane, whatever it's going to be. So if I'm going to say travel, and this would be kind of a generic front end type of a call where I'm instantiating a vehicle of some type and I want it to travel. This could be in like the main update loop of your game or your simulation or something like that. Well, travel is going to take a vehicle of some sort. Let's set its speed to 35 miles per hour, start driving forward, go left, and then start climbing. So think of a vehicle simulator where, cars going at 35 miles an hour, very slow because let's pretend the camera's pulled way back. 35 miles an hour, go forward, turn left, start climbing. I've specified a path for this car to go. I could replace the vehicle with boat, with plane, and it's going to be the exact same set of function calls, right? You're getting the idea, hopefully, of reuse, of extensibility here. This is very easy to update if we want to add in, say, another type of vehicle. What if we want to add a tank? It's just going to be implementing these methods. It's not going to be constructing the entire picture again. So reusability is great. I've got some links for Python examples here for you. Interfaces can be done in Python, can be done in Java, C#, C++. Again, it's the notion of abstracting things. If we know what kind of design pattern we're trying to follow, we can implement it in pretty much any language. Again, that's just the mechanical pieces of it. Did not want to click that. I wanted to take a quick sip of tea and then click the next slide. Okay, but that's the basics. One of the things that we really have to talk about here pretty quickly is the idea of the quality of your project, so the quality of your software design. This is something where it would go into the notions of technical debt, which I've brought up multiple times, right? That's how much future work you're signing yourself up for by being lazy at the front end. He said, looking at his little P5 projects and how much of a pain in the ass it's going to be to refactor everything now to be good. But with this notion of quality, we can look at how tightly coupled our classes are and how cohesive they are. These two metrics were proposed in the 70s and they still hold today. Basically, we're just looking at a module of some type, and that depends on your language, or it depends on your perspective. It could be a function, could be a whole class, could be a package, could be a procedure. It just depends on what you're looking at, right? We mentioned that some of the functional languages have like modules. Typical object-oriented languages have classes. Maybe you're doing C and all you have are functions and structs and pointers. So you're looking at functions at that point. But the idea is that we're going to look at these two metrics here. So what is cohesion? Basically, this is how interrelated things or elements are within a class or within a module. Basically, you're looking to see how single purpose your class is. So let me pop all the things that we have up here. So we have functional, sequential, communication, procedural, temporal, logical, and coincidental. Basically, what this means is that we have various levels of how interrelated things are. So I don't want to do that yet. Oh, we're going to get into all of these basically. So let's say that we have a God class, right? So that was an anti-pattern where you have one class that does everything. That would have the absolute worst level of cohesion because all of its responsibilities are just spread so far apart, right? It is doing too many things. It is not cohesive. It would basically be coincidental cohesion, which we're going to talk about these as we go, honestly. Basically, we have arbitrarily placed functions, arbitrarily placed attributes. If you look at that human resources God class thing that we talked about, where let's add an employee, update an employee, delete an employee, add payroll, add time off, add project effort. And if that's all one thing, it's not cohesive, it's too spread. That is a measure of poor software quality. So, question to you all, and again, we're going to get into what each of these mean here. If it is very highly cohesive, it is much more easier to maintain. And by being more cohesive, all of its parts are focused on a small, single, laser-focused task. How would you improve module cohesion? Oops, there we go. So I do for you all. Let's get you all talking here. Let's say that I have a God class, okay? Human resources manages everything in my company, one big class file. And this is managing my employee everything system. How do we improve that cohesion there? Any guesses? Even though I'm 3 rooms away, I can still hear my kids fighting. Any thoughts here? I don't know is an answer as well. Question is, are we just running slow today or is this not working? Let's see. That was my response. Okay, that's fine. We can keep moving on. So to improve cohesion, oops, see if it is viable and smart to break the object into an answer for every requirement and then do that. That's a good answer, right? We break it apart. No, that's fine. It's fine if you don't know. This is probably the first time we're talking about cohesion. This is a big problem in software development because it is very, very easy to put everything into one class file or small class files, right? You try to break them up. You try to make them single focused. So for our employee management class, everything employee profile related, so name, date of hire, social security number, address, put that in one class. Anything related to their time off reports, put it in another class. Anything related to the projects they're working on, break that off into another class. So if it makes sense to break it apart, try to break it apart. Cohesion is going to be single responsibility classes. And that's where you get maintainability, that's where you get reusability from. So functional cohesion, this is going to be the most desirable here. Everything is grouped together for one single well-defined, again, laser-focused task. That's your model view controller idea, right? When you do it in its purest form, the model is strictly working with the data. The view is strictly working with the presentation layer. The controller is strictly working with routing information between the two. They have their own jobs to do, and they do it very well. Yes, it's a little bit more complicated to implement, but the net savings that you get for years down the line is absolutely worth the headache in the beginning. Right, so that's functional cohesion. Everything is grouped together. Sequential cohesion is where, again, we have still split things up. And we're kind of going in order of desirability here, by the way. If I have one big class and I split it up into, say, 3 classes, we have this cohesion where, okay, I instantiate my first class. The output of this class is input to another. The output of this one is input to another. They still have more or less single responsibilities, but they're kind of lumped together with this input-output chain. Here, everything is well separated out. Here, we're tied together with, inputs and outputs, or returns and instantiates, or something like that. Communication cohesion, or communicational, we are going to operate on the same data set. So think of MVC, where your model is the same data for everybody in the system. Think of it as a high-level class diagram type of thing, visual. I've got classes 1 through 20, and they are all tied to the same model. Not as desirable because things are still tied together. We're kind of cohesive. There's coupling there too, but we don't have our own nice separation. Kind of like, in a way, normalizing your database tables. We have procedural cohesion, and this is where it may start to get a little confusing. We're going to group modules together because they follow the same sequence, the same order of operations. Basically, there's always going to be this, if we were to go back, way back to, this type of a vehicle interface-based definition. Let's say that every single vehicle we implement is always set speed, go forward, go left, and then climb. If every single one of my vehicle types does this, we would have procedural cohesion. So they follow the same order of events. There's temporal as well, which this is where it might be a little confusing. We have things being processed at specific times. So one is order. So set speed, go forward, turn left, and then climb. Doesn't imply that it's happening at the exact same time, though. With temporal cohesion, we would assume that things are happening at the same time within these different classes. And then there's logical cohesion, where basically we have some kind of like a logical grouping. So this is the data, this is the employee, this is the time off reports. Basically, logical is just kind of a categorization of your classes. And then coincidental, we just throw things together. Make your God class. This is not cohesive, very cohesive. So you want high cohesion. You want things to be very, very specific. So here's a nice little example here. If you've checked out that Geeks for Geeks website, which I think I've recommended about 30 times now for some of this type of stuff, you should recognize the style. A class like this has very low cohesion. This would be coincidental. We just kind of, actually it might not be coincidental. This might be more logical because it's check email, print letter, print address. So this is clearly, message delivery of some kind. Low cohesion. Everything is lumped together in one class. Here you have high cohesion. Everything has been split apart into its own specific classes. Now, yes, a little bit more complicated, a lot more moving parts, but more desirable from a software engineering perspective. So cohesion, hopefully that makes sense. Basically, you're looking at responsibility of your objects. And again, it doesn't have to be a class. It can be a module, it could be a function, just depends on your programming language. All right, coupling is the other aspect. And this is going to be how dependent things are between classes. So cohesion is responsibility. Coupling is how tied together things are. So if I have, say, 5 classes and they are all calling each other, inheriting from each other, instantiating each other, that is very, very tightly coupled, right? I've got all these little relationships between them. Now, relationships are a good thing, right? We've been talking about them in general, but the more relationships that you add, the tighter coupled things become. And if I have to make an update in class B, and it's very tightly coupled with classes C through Z, I'm going to have to also update all of those other classes to make the change that I made in class B work. So typically you want um, coupling by parameters, coupling via function calls. That's normal coupling, that's okay. Nothing too bad there. Um, then we also have common coupling and content coupling. So this is where maybe we share a global data space. So there's maybe a generic high level, maybe it's a global variable or a global class where it's got parameters and methods that we need. And if we have, classes B through Z, I'll reference class A. That could be like your common coupling. Not necessarily as bad, but not perfect. Um, Content coupling is the least desirable here, so you kind of see again the spectrum of good to bad. This is where we are directly talking to other internal parameters, other classes, their member attributes, things of that nature. So directly tying things together. So function calls, getters, setters, global variables, directly accessing. Good, mediocre, bad. Let me give you an example here as well. And this is less of a, kind of a nice pretty view, more of a generic circle-based view. If you have classes that result in a diagram that looks kind of like this, if you were to visualize it, you see lots of overlap, right? We see lots of direct access between them. This is not great. Very tightly coupled. All of these classes are interdependent on each other. If I try to yank, say, this one out here, it's going to break everything in these classes. It can be good from a ease of programming perspective, but again, that hurts you later on down the road. And you'll see this when you get into bigger projects, right? Simple class projects, even our term project, this kind of stuff we're talking about doesn't really impact you because you're not going to be maintaining it for 10 years down the road. You get into real world industry or open source projects, breaking your classes apart and loosening their dependencies becomes really, really important. So something like this would be more of a loose coupling where we just have like references to gets and sets from class A to class B. You want to tease things apart. That's kind of the goal here. We'll leave this question off for now, but basically the relationship between design patterns and what we've been talking about in these slides is that the design patterns are basically informed by these ideas of cohesion and coupling. We are trying to basically provide good patterns for programming based on what we as an industry know as is what you would basically want to do to reduce your overall workload over time, right? If I'm telling you to implement MVC on your project, that's because I know that this is an MVC problem. I know that this is going to be something that we as a team of 50 people are going to have a much better time working with rather than a big single page React application that is awful to debug. And then question here, is one better than the other? And this references OOP, OOD, OOA. I mean, they're all important in their own right. OOA we do at the beginning of the project to figure out which objects we're going to need. OOD we do to figure out, okay, how is our cohesion and coupling metrics going to look, right? How tightly related will these classes be? And then OOP, at least to me, that's just implementing all of this difficult mental work that you've already done. So they are all interrelated and they all serve their purpose. Again, think of it like you're walking through the high level UML diagrams to requirements to programming. They all basically inform each other. So, no, I don't want to keep that poll active. Thank you. Let's move on to decomposition. But if you have any questions on cohesion and coupling, please feel free to ask. Let's talk about decomposing our software. It's a forewarning. I've got, I think, at least 1 to 2 more zombie puns in there. So what is decomposition and why is it important for our 3 lovely object-oriented acronyms here? Well, it turns out that we actually may have a problem that has never been seen before in software engineering. So let's say that you're working on a new project and you're trying to figure out what design pattern to apply because you are analyzing your problem early on and trying to save yourself time in the long run. Maybe there's not a solution to your problem, right? Maybe MVC doesn't make sense. Maybe a singleton or a facade or an observer or any of the 23 plus design patterns that are out there. Obviously, there's a lot more than 23 now. Maybe none of them fit your particular issue, or you just don't realize it yet. Well, what we can do is we can decompose our problem. And all this really means is to break it into pieces. So let's take a big problem, a big question, just tease it apart. Let's break it down. We can look at multiple ways of decomposing problems. And based on what you're trying to figure out, you might go one decomposition method over another. We're going to start with object-oriented, that's why it's bolded. I'm kind of going in reverse order, but we can look at the data, we can look at the processes, we can look at features. Basically, what are we struggling with? Let's try to make it more attainable. So object-oriented decomposition, this is where, I'm trying to figure out what are the different aspects of our program that we're going to have to build. So if I'm doing an object-oriented type of decomposition issue, let's figure out what the objects are. Okay, this is kind of what we've been doing all class. Let's figure out the objects in our system. Let's figure out relationships between those objects. If I tell all of you, go out and build me an ERP system, which if you've never heard of that, that's what the SAP company builds. That's those advertisements you see everywhere at airports usually. That's going to be your enterprise resource planning software. So manage users, manage projects. It's big, massive web-based interface type of thing. Well, what are the objects? I need employees, I need projects, I need departments, I need people, I need meeting rooms. Everything's going to be represented in here, okay? So what are the object types? How are they related to each other? Very high level. Which modules are those objects assigned to? Okay, maybe if we figure that out, what are their attributes? What are their operations going to be? So what is the actual class diagram going to look like? If I start high, very broad and global in nature, I can see this problem. And then I start figuring out the pieces. Well, I can start figuring out what kind of programming is going to have to be done, right? Again, we're talking about all the mental work here. The programming work is the easy part once you get comfortable with programming. This is the hard stuff. How do we actually build the software and how do we assign team members to work on it? Okay, 3 of you work on the user interface, 10 of you work on the backend database, 10 of you work on how the database talks to the front end, right? So we can start assigning responsibilities too. And maybe with this decomposition, patterns start to emerge that, okay, our database has to be a singleton, or maybe a facade would be absolutely great to abstract the back end from the front end. These things just kind of start to appear here. So here we have let's see, what was this one again? I think this was related to a credit card based application. Yeah, I'm trying to, just looking at my notes for this particular thing here. But what we've got going on is update. So this card is throwing me off. This to me looks like a pure database application or a file system application, but card, that's throwing me off. Punch card. Basically, here we have a system where we are updating something. Either it's a file, either it's a database, or a card. Okay. Maybe it's a e-card of some kind. But let's go from a file perspective, because this is also looking like a file system to me. So we want to update a text file. Okay, so we're writing an operating system with this example. I want to update readme.txt. Well, user opens up the file, makes their changes, hits save. To them, the operating system magically saves it and it's always there. There's a lot of things happening behind the scenes though. We may have a master file system record. We may have a temporary file that's hidden that's kind of logging updates to make sure that if the hard drive crashes that we can restore that information. Um, Basically, there's a lot of moving pieces with a file system based update. And I'm taking a problem of update file and we're decomposing it into pieces here. All right, so we have the master file that the user sees. Well, maybe there's a master system record as well that keeps track of the actual state. And how does it do that? Well, it probably needs a checksum, which is just a calculation of its current state. And is it valid if we go to restore it later on? So it's almost like calculating a hash or something like that. Checksum is a cheap way to check validity. Spoiler, when all of you go into automotive, never use the checksum or the CRC for security. If you do, I will glare at you and come to your work and yell at you because this is not valid security. He said, sighing, thinking back to his days working on CAN networks. These are useless other than for validity checks. Don't think they're security. Waggling my finger at you from past experience, you have no idea what I'm talking about. But you can kind of see that these boxes here are all objects. They all obviously will have attributes and methods inside of them, but this would be a high-level decomposition. Let's break things apart. So that's object-oriented. Functional decomposition, this is where we're going to take objects, we're going to take modules, whatever perspective we're looking at. Let's figure out what functions it needs. Okay, so which functions are going to be required by the system? So something that can be useful to think of for functional decomposition is, consider an embedded system where instead of big high-level object-oriented classes, we have very purely procedural function calls. So we're going to initialize our system. We are going to load data into our registers. We're going to configure ourselves based on what our customer wants. We're going to run our execute loop, which goes forever at a particular tick rate based on CPU cycles or something like that. Basically, very action-oriented, very functional, very procedural. So what does this mean to do a functional decomposition then, and why does it differ from something like this? Well, an object-oriented system, we're going to have a lot of objects, a lot of moving pieces. A functional system, we just have to figure out what are the steps, right? Maybe what is the state machine of our object? How do we tie that with our requirements? Which modules, which functions are going to call each other? Basically try to think of kind of a system where we're looking at interrelated dependencies. Again, more function oriented in this case. So here we have a example of a hotel system and not really a embedded system example, but we have high-level functions for this one. And kind of the goal of showing you this, but talking about embedded here is that the terms are kind of up to your own definition in a way. Functional could mean embedded. Functional could be just that we have a system with a bunch of functions that we have to define. So here we have a hotel system. What do you do at a hotel when we don't have a pandemic? Well, you can go into their web portal, Let's reserve a room. Let's manage our room reservation. Let's maybe get some services reserved. So if we need somebody to bring us up room service, maybe we want to get some information about other people's reservations if we're the manager, if you're going to clock in. These could all be described as functions that we call. So I visit Expedia.com and I pull up the local Hilton. Hilton Grand Rapids reserve room could be a function, right? We pass in the date, pass in the user ID. That's one thing that we have to do as a system. Well, this makes sense. So let's pretend like we're hiding. Let's do this very quickly here, since we got a few minutes. And we've got not too many more. This is a good example. We'll fly through the other ones. Exit full screen. Stop presenting. There we go. Heck. So we have a hotel system. All right, let me show you a decomposition here. This is your problem. Go build me a hotel system. Okay, sure. What do we have to do? Well, we have to provide these services, right? These functions are going to be calls that our system can make. Okay, well, what does it mean to actually reserve a room? I don't know. I don't know how to program this. Well, we need to be able to log in, check if it's available, check promotions, record the reservation. You can go further and further down. Basically, we're decomposing this big problem into subproblems. Decompose that problem into subproblems. You could then take these specific activities, either break them into requirements, break them into objects, just depends on what you're doing here. But we're just taking a big problem and making it easier to work with. And again, depending on your perspective here and what you're focusing on, that will kind of help guide your decomposition. So we also have feature-oriented, and depending on your perspective, this might sound very similar to function. Basically, we have a feature model of a system. So think of something like a Photoshop or GIMP or other version of a photo editor of some kind. Let's say we want to add a feature of some kind. So here we have a pattern feature. Okay, well, I draw a little vector square on my screen, and I want to add a texture to it. I want it to be stippled, or I want it to have a metallic sheen to it, or whatever you would do. We could consider that a feature. Okay, so maybe we have this texture feature that we can apply. How do we break that down? Well, if it's a stipple pattern, that's like your pencil points, artistic style. How big are your pixels? What's the color of each pixel? Is there a gradient, right? So these are all separate features that we're applying to a problem. And again, the high level feature here would be, well, let's build a image processing model. What are all the sub features? What are all the things that it can do? Right? What are all these little attributes that we can apply? If you're doing Unity, our feature model could be that we are adding a object to our scene. Was that object a capsule? Is it a cylinder? Is it a cube? Is it a sphere? Are those then broken down into a mesh where you have the geometry, the topology, the texture? Feature and function can be kind of similar if you look at them, but the nuances are a little bit different there. All right, we also have data-oriented. So this is where we're going to take our system and figure out where the data is going to go and how we're going to be using it. Again, we're looking at different perspectives here. So those of you that were talking about the ER diagrams a few weeks ago, this is your data decomposition model. How is your data going to kind of filter and work its way through your application? So here, let's do a high level and low level design again, where high level would be the data structures that we are using to store data, right? So your ER diagram would be your normalized database tables, for instance, or it's going to be a description of your JSON documents that get loaded into your various modules. The low level design then, let's figure out where that data is flowing to. Let's figure out how it's going from class A to class B, or maybe function X is returning the JSON packet that we pulled from the server, which is then transformed to XML along the way or something like that. So maybe helpful to think of data. So here is I'm just looking, it's a random slide that I pulled. Let's say that we have a project where we spec out its requirements, right? Something that we should always do. Well, now we have to figure out how we're going to implement a data model here because these requirements, maybe we're dealing with a NoSQL database, right? Let's talk to Mongo or Couch or Bigtable or something like that. How are we going to represent that internally? Well, maybe I need a bunch of structures to hold the various data sets that we're pulling in. Okay, well, if I've got requirement 1 here, that's going to be tied to A and B. Requirement B is tied to this structure, but it doesn't talk to this one. And then we can start breaking things down. Again, the key here is not really to get hung up on the actual application and, these little examples that I'm showing you, but just to show you how we would tease apart these various problems that you're going to face. Right, those of you that are doing the MVC application right now, because maybe you didn't get it done yet, and it's a busy semester. Some of you are going database, some of you are going flat file, some of you are just instantiating objects in memory. This kind of data-oriented decomposition would be how you're representing that data in your program. So here's another way to look at data decomposition too. This is a big application where we have a cloud storage-based system. We have basically antennas that are distributing data from some kind of I don't know that this necessarily would be on premises, but maybe it's a globally distributed set of servers where these servers are transmitting data to users in the field or something like that. So a big distributed application here. Or cloud storage, maybe this is in Google Server Farm, maybe it's up in AWS, DigitalOcean, pick your cloud provider of fancy. We have a bunch of files that are stored up there. Okay, so these files are stored, however it's going to be represented internally in your cloud. We would replicate those files down to some local servers. Those local servers look like they probably have a database of some kind where they're going to store that file. And then the application software running here, making use of some kind of a base station, probably just Wi-Fi or, data or something like that. Phone data, sorry. We transmit data over to the user's mobile device with, a bunch of steps along. Obviously, I'm hand waving all of this. But you can kind of see that if we're decomposing our data model here, high level, we're storing data up in the cloud in a particular fashion. We're going to decompose that into local files here, which get transmitted to user files. And this could be a very complicated application where we could tease apart this data model as we go. All right, we also have process-oriented. So different way of looking at it. Maybe we'll talk about like a data flow diagram, maybe a kernel diagram. Basically, what are the processes that your system has to do? Process A, process B, process C, right? Process to load program, process run user query. Just a thing that your system has to do. How do these processes interact with each other? When do they have to run? What are the inputs? What are the outputs? What type of data is being consumed at which point in time? This could be like a operating system task-based model where you need to run processes at certain points in time for everything to work. Just depends on your perspective again. So how do we break things apart? What are they going to be doing? This would be a high-level order processing example here, where a customer wants to visit a store, whether it's online or in person, and we're going to try to buy something. Okay, so I go to a store's website, say, I see what products are available. I go ahead and order something from sales. Sales processes the order, verify the customer data, verify their accounts. Store would send the item. The sales department pays for shipping, delivers it to the customer. Kind of a generic figure here. This would be like a data flow diagram type of example. We're seeing the activities happen in between our various objects. We're seeing the kind of order of operations that would appear, usually the diagram like this, you'd specify the start and the end a little bit clearer. But we're breaking up the processes that are happening here. All right, we got a couple minutes and a handful of more slides. We also have event-oriented decomposition. So this is useful for you in the object-oriented domain. Basically, what are the events that we have to handle? What are the callback functions that we have to define? Right? If the user clicks the screen, is that going to trigger a callback event that we have to deal with? Right? If it's a high level, we're going to look at what we're expecting event-wise to happen. If it's a lower level design, let's take these high level events and figure out exactly what this event means, what it's getting triggered, what has to happen, what are the outputs. Basically handle event-based programming. And then you kind of get like a state diagram that looks kind of like this, where we start here, we're waiting. Okay, we are at full power, go here. This would be kind of like a clock-based example, like a clock that you plug into the wall or something like that. Or, oh no, sorry, this is an oven, not a clock. I'm looking at time. But you see events happening here, right? We're waiting. When something happens, move to the next state. All right, decomposition pun. Kind of the key here is to figure out what type of decomposition is useful for you. Right, I've given you a whole laundry list of decomposition approaches, and it's going to be up to you to decide which one that you want. Right, here we're decomposing multiplication into a bunch of sub-objects. Right, so here we have addition, we have a subtraction, we have literals, we have a literal up here, we have a multiplication object at the top. This could be data-oriented, so we are focusing on the data here. Could be object-oriented because we're building objects along the way. Again, here this would be an event-based type of thing. But the key is that if you have a problem that you're trying to figure out what to do, like the next homework assignment, if we had another one, I would say, build me X thing, and I don't give you any details, right? Well, you start off, what do I need to do to build this system? You can't just jump into requirements, and you can't just jump into programming without knowing what objects you have, how they're going to talk to each other, what the underlying data model is. All of these moving pieces does tend to factor in. Okay, that was decomposition. Wrapped up OOA and OOD, which is good. Next time we will get started with unit testing, which is going to be lots of fun. You get to watch me probably fail horribly at Java. But any remaining questions? Or are we all good? Otherwise, I see a question. Okay. In the MVC assignment, you say we should have 2 views. Does that mean you want 2 separate scripts or 2 distinct view modes within one script? This would be a good decomposition question. I don't care how you represent it. What I want to see are 2 separate view types. So there should be a view that is displaying the full product listing. There should be a view specific to a single project. However you represent that is completely up to you. Does that help? Yeah. That's where a lot of this stuff is kind of up to you, the user. Sorry, let me make this a little bit lower. It is a good question because it kind of asks, the purpose of the whole MVC model. As long as you can demonstrate that there are 2 views, I'm happy though. All right, I will kick off our office hours in a few minutes in Blackboard. Hope you all have a wonderful day, and I will see you on Friday. Bye, everybody. Let's do a PogChamp today. See ya.